Construct a truth table for a conditional statement. Let's start with a conditional. What is a conditional statement? Well, you're often going to hear conditionals described as if-then statement, right? If it rains, then I will wear my rain boots. That is a conditional statement. Conditional statements are only false when the front is true and the back end is false. So if we're talking about if P, then Q, P would be the front and Q would be the back, right? So the front is where it starts, the back is where it ends. Okay, so let's go ahead and jump into this. Construct a truth table for this statement. P and not Q. If P and not Q, then not P or Q. Some pieces to this. Okay, so we know that we have P and Q. So since we have two items here, we're going to have a truth table with just 4 lines because 2 squared is 4. Now, we're going to focus here on this first piece. So I need to negate Q first. And remember, if we're negating, that means we are taking the opposite truth value. So Q is true, false, which means not Q is false, true, false, true. Now I'm ready to do P and not Q. So remember that and, right, the and statement, the conjunction, means that we are taking, both need to be true. So when I'm looking at P and not Q, they both have to be true for this to be true. So I'm looking at true, false. Well, they're not both true. True, true. Yep. False, false. No. False, true. No. So my line is false, true, false, false. And that's the first one. Okay. So now we can look at our second piece. And the first thing we have to do is negate P. So let's go ahead and negate P. So instead of being true, true, false, false, we are false, false, true, true. And now we can do not P or Q. We are dealing with a disjunction here, an or. So when I'm looking at not P or Q, as long as one of them is true, the disjunction is true. So false, true, yep. False, false, nope. True, true, yep. True, false, yep. Okay, and now we are ready. Now we are ready for if P and not Q, then not P or Q, because I'm comparing, right, these two together. So remember, with this conditional, it's only going to be false if the front end is true and the back end is false. So this here is the front and this is the back based off of the order that they are here. So I'm going with false, true. Okay, so we're going to be true because we are only false when the front is true and the back is false, like you see on the next one. So that's false. False, true is going to give us a true. False, true is going to give us a true. So our truth table last column is true, false, true, true. And let's do one more here. Consider the statements below. What is the truth value of P and Q? If P and Q, then not P. Okay, so first of all, look at what we're given. P is 4 plus 5 is greater than 2 times 2. Well, that's 9. Is 9 greater than 4? Yes. So this is true. And Q says 7 is less than 2 times 3. Is 7 less than 6? No. So Q is false. So when we're thinking about our truth table, we are only concerned about when P is true and Q is false. So when I'm looking at my conditional statement, first I'm given P and Q. So let's go ahead and find that. What is P and Q? Well, in this case, to have and be true, they both have to be true. We have true, false, so P and Q is false. Now, if I'm looking at not P, to the other side, well, okay, let's change that. So P is true, so not P is false. Great. Now I can do my conditional. If P and Q, then not P. So remember, with a conditional, we're only false when the front end is true and the back end is false. So this is my front end and this is the back end, right? Front, back, front, back. So my front end is false and my back end is false. Well, That's great. That means our conditional is true. So the truth value of if P and Q, then not P, in this case, is true.